So we're really close now. Just one more video to go and we'll have our Uber app complete. What do we need to add in this video? Well, it can be summed up in a single screen, and this is what we're going for. So we want the user to be able to see the driver's location. So there's the driver there, and we want them to be able to see exactly how far away the driver is. So you're going to need to find a way to scale up your map to show both the user and the driver's location and to work out the distance between them. I'll give you a big warning here, and there's an issue with parse, a bug or a feature depending on how you look at it, that you cannot have two PF geo points on a single object. So you're going to need to create a new class to store your driver's geolocation. Other than that, it should all be reasonably straightforward. So best of luck. Hope it goes well. All right, here we go then. For once, I'm not going to start with a new view controller because we have all the view controllers that we need. I'm going to start at the driver view controller and add the code to save the driver's location on parse server, because we'll need that here so that the rider can access it and view how far away the driver is. And then we'll look for where the location is updated. So that's in did update locations. And what we'll do is another query. And this query will look to see if there is a rider request that our rider has responded to. So if I do a full page request there, we'll see the new driver responded field. And if there is one that our driver has responded to, then we want to update the location of that variable. There we go. So in my testing, I've got 2. So let's set that back to 0. So we're just working with 1. Okay. So let's create a new query. Actually, let's order everything a bit more logically first. So I'll call this a driver location query. It's still going to be a PF query on a class name of rider request. And the where key this time is we're looking for where the driver responded is equal to the current user's username. And that's all we need to know. So then let's find objects in background. And all we want to do is update any objects that we find with the user's location. So let's check to see if let rider requests is equal to objects. And if that's true, let's loop through it. And then we'll just take rider request and set driver location, which is a new variable. We haven't added it yet. We don't have it anywhere here, but we can just set that equal to a PF geopoint created from a latitude and a longitude. And this is then going to be user location dot latitude and user location dot longitude. And then simply rider request dot save in background. There we go. I think we might need to force unwrap that. And of course, don't forget yourself. Okay, so now we have the one rider request with our driver responded. So we should be able to go back onto our parse server and refresh that, and now we'll see our driver location, and it will update automatically as our driver moves around. And oddly enough, it's not there. And this is an interesting bug that I thought was worth bringing your attention to, because it's definitely one that I've come across before, that in a PF object you can only ever have one geopoint. So it's just one of those limitations that parse server has. So we're going to need to save our new driver location to a different PF object. So not a great problem. We can change our class name to driver location, and this time we'll have a username and a location field. So we'll look for driver locations instead of rider requests. And if we find one, we'll set the driver location, which I'll just call location, and then save it in the background. And if there's not one there, then we need to create a new one. So we'll do a check to see if driver locations dot count is greater than 0. Then we'll update them. And if it's not, then we'll create a driver location. So our driver location is going to be a PF object with a class name of driver location, and it's going to have a username and a location. So the username is going to be the current user's username, and the location is going to be not the current users, but it's going to be a PF geopoint created from the user location. So that's user location dot latitude and user location dot longitude. And we're going to need self for both of those. There we go, and then driver location, save in background. Okay, so remember that if you're pulling your hair out trying to work out why a second location variable is not saving, that'll be why. So let's just have a look. This is now running, so we should now see a new class on the left of driver location, and we should see our current driver's location in there. There we go. Okay, so we have our driver's location, but oddly we have it 4 times. Now that could be something to do with the particular timing of the requests, but perhaps a better way to deal with it would be to delete the old driver location and then add a new one each time, regardless of whether there were any existing ones. So let's copy that out, or cut that and put it outside the if let. Statement. So now we're just going through and deleting all the existing locations and just adding one new one each time. So let's just check that. See if that gives us the single driver location that we're after. It does indeed. Wonderful. So now we have our driver location merrily updating. It's just a matter of displaying that to the user. So let's go back over to our user account. I think it's Rob Ryder that's been accepted on this rider request. So let's just check. Yep, there he is. So I'm going to log in as Rob Ryder. So we need a way to show him that his request has been accepted. So I'm going to do that over in Rider View Controller. And what I'm going to do is to check when the location is updated, which is here, whether or not the request has been accepted by a driver. So first off, we only need to do this if rider request active is true, because if they don't have an active request, they're not going to have an active request accepted. So if that's the case, we'll set up a PF query on our class of rider request, and we're looking for a rider request where the driver responded is something. And as before, we're looking for the rider requests where the username is equal to our current username. Strange bit of autocorrect there. Current.username. And then we'll run that query. So find objects in the background. Let's just get the unwrapping. I suspect there'll be another one to do as well. There we go. So we'll find objects in the background with block. And as usual, let rider requests equal objects. In fact, it should be if let rider requests as objects, then we're going to loop through them. So for rider request in rider requests. And then, let's just get out. Unwrapping finally, right? So if we're here, that means we have a rider request, but it doesn't necessarily mean that someone's responded to it. So let's test that out by taking if let driver username is equal to rider request and driver responded. So if we get a value there, if it's not nil, then we have a driver that's responded. So we're going to need to get that driver's location. So let's do a new query. It's a PF query, this time with a class name of driver location, capital D. And then we'll set the where key to, this time we want the username to be equal to the driver username. So just to remind you what we're doing, we've taken our initial rider request and now we're checking the driver location for that particular driver. So the driver that's accepted our request. That's all we need. So when we've got that, find that in the background. Objects and error. So we're checking for driver locations equals objects. Then we're looping through driver locations. And the specific thing that we want is a driver location. So I'm actually going to change that to driver location object, and we'll let driver location itself be an attempt to take driver location object and get the location as a PF geopoint. So if we're there, the two key variables that we need are driver location and driver username. But by the time we've got to here, we've definitely got a driver on its way, so we can tell the user about that. And I think I need a capital P for point there. Okay, so there's a number of ways that we could do this, of course. I'm going to do it sort of cheap and dirty way by updating the button. So you'll remember we've got the call an Uber button. So I'm going to update that to have a new text. So call an Uber button, set title, and we'll have driver is on his way. So I'm just going to leave it for that at that for now, before I do anything more complicated, just to make sure that these various queries are working as expected. And most importantly then, we should get that button updated to driver is on his way. Might take a little while. And there we go. So it has updated. The driver is on his way, but we do need to give the button a little bit more room to breathe. So let's stretch that out to the edges of the screen. Okay, so I'd particularly like to tell the user how far away the driver is. And that's actually quite easy to do. We've done it before. We just create a CL location variable for each of our locations. So the driver CL location is going to be a CL location based on a latitude, which will be driver location dot latitude, and a longitude, which will be driver location dot longitude. Then we'll have a rider CL location, which will be a CL location based on the rider's latitude and longitude. Remember, the rider's location is this user location variable. So now we just use user location dot latitude, which it doesn't auto predict for some reason, and user location longitude. And then we get the distance between them. So the distance is going to be rider CL location dot distance from driver CL location. And just as before, that's in meters. So we'll get it in kilometers, and then we'll have our rounded distance to get it to 2 decimal places. So we'll take our distance, multiply by 100, round that to the nearest whole number, and then divide it by 100 again. And now we can set the title of our button to your driver is, and then rounded distance, kilometers away. Okay, and I've forgotten myself yet again. Okay, so let's try that out. We now should see the driver's distance. And yes, that should be driver's CL location, because the distance method only works between two CL locations. So yeah, now when we run the app, we should see the driver's distance away. All that remains then is to show the driver's location and the rider's location together on a map so that the rider can see how far away or where exactly the rider is. Okay, I think I may have inadvertently cancelled the rider request that I was relying on. Yes, I have indeed. Okay, not a major problem. So let's create a new one. And then update that. And I'll just manually add the driver to it. So there it is, Rob Rider. And we'll add in Rob Driver. And there we go. It's updated automatically. Actually, the driver is very close indeed, 0.00 kilometers away. We could change the driver's location to make that a little more interesting, just to show that that's working correctly. So if we change that to, say, 37 and jump back, we now get your driver's is 34. 37. So the driver is driving around. Oh no, it's the user that's actually moving at this point. Okay, fantastic. So now we have the information for the user, telling them how far away the driver is. The final thing then is to show both locations on the map. Not as hard as it sounds, but not exactly trivial. Okay, so we're going to need to set the user's location in the center of the map, and then we're going to need to scale the map appropriately so that we know that the driver's location will appear on the map, but won't be too close to the center, won't be too far out to the edge. So this requires a bit of an understanding of what lat delta and lon delta are. So remember, all they are is the change in latitude from one side of the map to the other. So we want to make sure that that change covers the distance between both of our driver and our rider. So what we can do is take our driver location, get the latitude, subtract from that the rider location's latitude. So we can use user location dot latitude for that. We don't know which one of those is going to be bigger, so I'm going to use the abs function to make it positive regardless of which is bigger. So that's the distance, or the change in latitude from one location to the other. Now we don't want that to be more than half the screen. So I'm going to multiply that by 2 and add a little bit. So say 0.05. In fact, 0.005 is probably better. So this will mean that this distance is a little bit less than half the screen, which, if our user location is in the center, that's exactly what we want. So let's do the same thing with our lon delta. This is going to be driver location dot longitude minus self dot user location dot longitude multiplied by 2 plus 0.05. Oops, 0.005. Okay, then we create our region. So good old MK coordinate region, there it is. We're going to create that using the user location as the center, and we'll create our own MK coordinate span from our lat delta and our lon delta. Okay, then we'll set up our map. So we'll set the region to our new region. Make it animated. And I'll just add in a parenthesis, correct my equal sign there. And finally, we'll add both annotations onto the map. So let's create a user location annotation, which is going to be an MK annotation. It's going to have coordinates of the user location. We'll give it a title of your location, and then we'll add it to the map. And oh, that should be MK point annotation. Okay, then we'll do the same thing for the driver location annotation. That's going to be an MK point annotation as well. Then we'll need to set the coordinates for that, and we're going to need a CL location coordinate 2D created from the driver location variable. So driver location dot latitude and driver location dot longitude. And then we'll set the title to your driver. You could put the username there if you wanted. We do have it. And then let's add it to the map. Okay, so yep, quite a bit of code there, but hopefully fairly self-explanatory. One thing we're going to need to be aware of is that we're currently updating the map twice here. So this is going to cause a problem. It's going to jump back and forth between those two map scales. So what we'll do is have a variable called driver on the way, and we'll initially set it to be false. And then we'll set it to be true when we've got the driver location, which is just here. So driver on the way now becomes true, and we'll only update the map in this way if driver on the way is false. There we go. Okay, so let's test it out. We've done quite a bit of code there. Hopefully no major issues. But the main change that we've made is to now scale up the map so that we can see both the driver and the user, as well as see how far away the driver is. And there we go. So the driver is now quite a long way away from the user. Hopefully it's on its way, who knows. And there we go. So we've achieved what we set out for. The user can now sign up, log in, request an Uber, and then On the driver side, they can see the available Uber requests and accept them if they want to. When they do, they get directions directly to the initial user, and the initial user themselves is updated with the driver's distance and their precise location so that they can see them coming towards them on the map. Wonderful. Very slight thing that you can see going on here is that it would be worth removing existing annotations from the map before we refresh it. So let's just quickly do that. Remove annotations. And we remove all of the annotations from the map. There's of course a lot more that you could do to take this app further. Firstly, add a self in there. We don't currently have a way for the driver to cancel. Now that's in some ways a good thing perhaps, but this might be an option that you want. So for the driver to be able to click cancel and say that they don't want to get the rider anymore. We obviously don't have any payment mechanism built into the app as yet, and we don't have any kind of messaging or rating features or anything like that. But we've got the basic functionality there. And so a big congratulations for getting to the end of this section. It was a really meaty app, and I hope you managed to build the majority of it at least yourself. You now are really in a position to build pretty much any app that you want. And probably you're getting to the stage where you may have an app that you want to put it on the App Store. And that process is easier now than it used to be, but it's still not quite straightforward. So we'll be seeing exactly how to do that in the next section.